Hoff here.
Charlie here.
We're going to be teaching you about tension problems in 2D.
In these problems, 3 pieces of information will be given to you. The weight of the object pulling down on the 2 cables and the 2 angles of the cables down to 0. Before you start this problem, you'll need to understand a few key concepts. The first concept is that when an object is at rest, the sum of all forces is equal to 0. The problem asks us to find the tension of cable 1 and cable 2. Each arrow on this diagram represents a force. The bottom force is given at 20 pounds, and we're trying to find the force of cable 2 and cable 1, also known as the tensions of each cable.
Okay, for these problems, we're going to be using a system of equations to get our answer. And because the sum of all forces is equal to 0, the 2 equations that we end up having will be set to 0.
As Schoff said previously, we're going to use a system of equations to solve this problem. To do this, we're going to find the x and y values of each component of the diagram, or each line of the diagram. To do this, you're going to make each line into a triangle. To find each component of the triangle, you use the sine and cosine of the angle. For cosine, which is the x value, the bottom, it is the cosine of 45 degrees times T2. Because, as Peggy Herbert told us, SOHCAHTOA, cosine is adjacent to the angle, this is the adjacent side, times the hypotenuse, which is T2. The next, to find the other part of the triangle, you use sine, because sine is opposite, so opposite of the angle, times the hypotenuse, which is T2. So, therefore, sine of 45 times T2.
Okay, for this triangle, we're going to be using the same concept, but a different angle than's actually given. So if you look over at this unit circle that we've drawn, there's a triangle right here, and then the triangle right here, just like the diagram that we have. Where this, as you know, the range for an angle can be 0 to 90 in the first quadrant, but because this triangle is going to be in the second quadrant, the angle has to be in between 90 and 180. Our given angle is 55 degrees, so to find the real angle that we'll use in our problem, we're going to do 180 minus 55 to get 125. Okay, so now that we know the angle value that we're going to be using, we're going to do the same cosine and sine method using SOHCAHTOA.
Peggy!
So on the x value, we're going to have cosine of 125 times T1. And then for our y value, or the sine value, we're going to have the sine of 125 times T1. Alright, there's one more crucial piece of information that we need to solve our system of equations, and that's the 20 pounds of force pulling down on this arrow here. So, although we can't make a triangle out of this line, what we're going to do is look over to our unit circle and see that this line is at a 270 degree angle, which is crucial to solving the problem. So now, as you can see, there's 20 pounds pulling down, so the 2 equations we'll be using is 20 times the cosine of 270 degrees for one, and the other will be 20 times the sine of 270 degrees. Alright, now you're ready to solve your system of equations. We're going to have 2 system of equations, one dealing with our cosine values. So we're going to be using our T1 cosine value, our 270 degree cosine value, and then our T2 cosine value, and then the same for our sine values, which will both be equal to 0.
Here we put together our 2 equations by adding the y values of each force, or the sine values of each force, and adding the x values of each force, or the cosine value, and putting both equal to 0, because the sum of all forces when an object is at rest is equal to 0.
Alright, so for this next part, you have to get out your fancy calculator, and you're going to simplify your equation. So here we've plugged in the sine and cosine values. All you have to do is put sine, make sure you're in degree mode, of course, and then you're going to put in the angle And yeah, you're going to get your simplified decimals. After that, you're going to just pick an equation to solve. And this one obviously is much more simple because it's two components that are equal to 0. So that's the one that we're going to solve for. Okay, now I'm going to give you guys a second to pause the video and solve it yourself. Okay, now that you're done solving, I've gone ahead and just broken it down, simple algebra. So we have this equaling to 0 as before. So we're going to add the negative over to the other side. And then right here we're going to divide both sides by 0.707 to solve for T2. You can also go and divide both sides by 0.573 if you want to solve for T1. It's whatever you want. So here I'm going to plug it in to my calculator. And the answer is going to be T2 equals 0.810.
So now that we found that T2 equals 0.810 T1, we're going to substitute it into our first equation up here, which is this one. So down here, I added 20 to both sides, and then where T2 is, since we found what T2 is equal to, we're going to substitute it in. So right here, I substituted 0.810 T1 for T2. So now you multiply 0.707 by 0.810, and over here you get 0.57267. And then you simply add 0.819 T1 to that, which is 1.39167, and divide it by 20 to get 14.37. Now that we've found that T1 equals 14.37 pounds, we can plug the T1 into any one of these equations. I picked T2 equals 0.810 T1 just because that's the easiest one. So over here, I simply plugged for T1 14.37 pounds and multiplied it by 0.810 to get 11.64 pounds. And our final answer would be then T1 equals 14.37 pounds and T2 equals 11.64 pounds. And don't forget your units.
Alright, to summarize, an object at rest will have a sum of forces that equals 0. Also, the angle in the second quadrant must be subtracted from 180. You can't forget that. Third point, you gotta remember SOHCAHTOA.
Peggy!
Shout out to Peggy. Fourth point, use a system of equations to solve and never forget your units.
Thank you.
Thank you.